Alright, here we go with video 5-5. This one's going to be on inequalities involving absolute values. So it's going to build upon compound inequalities from the last section. So get right to it. Problem solving tips. With any absolute value problems, even before when we were doing equations, we had to consider two cases, one for the positive and one for the negative. So the same thing is going to be true here for inequalities that we had before. So the other thing to remember though is that when you branch an absolute value, because you make one of the numbers positive, in this case you have to flip the inequality when you change the sign, because just like we learned before, multiplying by a negative number flips the inequality sign. So we'll see some examples where we have to do that. And then when you branch you have two inequalities, so it becomes a compound inequality, and you have to know whether to use and or to connect those two inequalities. So there's a simple rule to remember it, and I'll try to describe why it makes sense. So when you're solving an inequality that's a greater than, you use or, and so you can say like greater, so say greater and it sounds like or. And then if you're doing compound inequality or using absolute values, and you have a less than, it kind of sounds like less than, so and. The reason this makes sense is say you have like something here, x plus 5 absolute value is greater than 5. There's two situations. The stuff inside could be larger than a positive 5, so any number bigger than positive 5, which would work, or it could be less than negative 5. So this leads to x plus 5 is greater than 5, or x plus 5 is less than negative 5. Right, and it's or because anything bigger than 5 works, and anything less than negative 5 works. So we change the sign from positive to negative, and we change inequality from greater than to less than. On the other hand, if we would have had x plus 5 absolute value is less than 5, that means we want small outputs. So anything less than 5. So x plus 5 less than 5 would work. But here we have to put and, then we would put here x plus 5 greater than negative 5. Okay, and so this means you have to be between 5 and negative 5. So I wrote here combine into a between inequality. So I can take these two things and I can actually write it like this: x plus 5, which is the piece here. The absolute value has to be less than 5, which means it has to be less than 5 but greater than negative 5. And so you can put this part from inside the absolute value in between the two extremes of 5 and negative 5, and then you can solve it all at once that way. So good to remember. Then the last problem solving tip is to remember that you cannot have a negative outcome for an absolute value bar. So if you have absolute value of x plus 5 less than negative 2, okay, that's going to be no solutions. Right, because the absolute value is never negative, so it can't be less than a negative number. But on the other hand, if you had x plus 5 is greater than negative 2, what's the answer here? Well, the absolute value stuff is always bigger than negative 2, because the smallest it will ever be is 0. So this would be all solutions. So instead of worrying about branching, if you have a negative on this side, it's either all solutions or no solutions, because you're either never negative or you're always bigger than a negative. Alright, let's do some examples quickly. X plus 7 is greater than 10. So we're going to branch. We don't have to do any solving because we already have the absolute value part by itself. So we have x plus 7 greater than or equal to 10. And it's a greater, so or x plus 7 less than or equal to negative 10. So we're outside of this range. We solve very easily. Minus 7 on both sides. Cancel. X is greater than or equal to 10 minus 7, which is 3. Or minus 7, cancel. X is less than or equal to negative 17. So on our number line, we have here 0, we have here negative 17, and we have here 3. So we're going to be larger than 3, so open circle at 3 going that way, or less than negative 17. So open circle here, going that way. So all of this is an answer, and all of this is an answer. So everything except this middle part. Next one. If the stuff in absolute value bars is not already isolated, remember that we have to get that part by itself. So the first step here is going to be add 4. Add 4. Cancel. So we have 4x plus 10 inside the absolute value bars is less than 16. So here we're going to branch, but because it's a less than, it's going to be an and when you branch the and, you can actually do an in between. So we can go 4x plus 10 is less than 16, but also 4x plus 10 is greater than negative 16. So this stuff here, 4x plus 10, is in between 16 and negative 16. And now we can solve both branches simultaneously, which is pretty cool. So we can go minus 10, minus 10, minus 10 from all three sides. Cancel, cancel. So on this side we have negative 26 less than 4x less than 6. And the reason it works to do all three sides at once is because as long as this inequality holds true, the golden rule still applies. So if you subtract the same amount from everything, the relative size of what's biggest, what's in the middle, and what's smallest will still hold. So our last step here is to divide by 4, divide by 4, divide by 4. So 26 over 4 is negative 13 over 2 less than x less than 6 over 4 reduces to 3/2. And so on a number line, we can plot our solution. Put a box around it, that's our answer. We've got 0, negative 13/2, and 3/2. Okay, so everything in between those two extremes, so open circle, because it's just a less than or greater than, no equals. Open circle here, and then we shade everything in between. So anything in between those two is your solution. Alright, one more quick example, and then we'll be finished. Absolute value of 5 minus x times negative 3, etc., etc. So you first notice that you've got the absolute value mixed in with some other stuff, so you have to get that part by itself, just like always. So minus 2 on both sides. Cancel that. That's going to give me a 9. And I'm going to go ahead and do this next step in the same spot. So I'm going to then divide by negative 3. So that's gone. So divide by negative 3. So I'm going to have 5 minus x. Now, because I divided by a negative, right, I have to change this inequality from less than to greater. 9 over negative 3 is negative 3. Okay, so what I have here is absolute value of 5 minus x is greater than or equal to negative 3. And like we said before, whenever you wind up with a negative in your absolute value problem, the answer is either all solutions or no solutions, just depending on whether everything works or nothing works. So the output here, this is 0 or positive, but it's never negative, right? So 0 is bigger than negative 3, and all positive numbers are bigger than negative 3. So the answer is all solutions. Now you could actually branch all solutions. You could actually branch this into two cases, but remember that when you have a greater, it's an or, okay? And so when you plot the solution, one of the two solutions will shade all the big stuff, and the other one will shade all the small stuff. But since as long as either one shades it, then everything is getting shaded, so you get all solutions. So keep a lookout there. If you have a negative in an absolute value, you can get either all solutions or no solutions. Alright, we'll do some more examples in class, but that's good enough for now.